Thank you, Michael. It's my pleasure to be on this talk. Thank you for giving me the privilege, and everybody who's joining us, thank you for giving up your time. And I hope that at the end of this session, you find it useful. So like Michael said, I'm just going to talk to us about the immune system and how our body fights infections generally. Now, this is can be quite a complicated topic, and I'm going to try and make it as simple as possible. Okay, and I'm going to be using mostly pictures. So this is just a picture highlighting how our body fights infection. So I'm going to use viruses from going on forward because obviously we're dealing with COVID, and COVID is a virus, but obviously this doesn't only work for viruses. So our immune system has two kind of broad categories. We have the innate, which is also the physical part, and then we have the adaptive system, which is, the internal part. So when our body comes in contact with a virus, it's got the physical barriers to try and protect you from catching this virus. So going from our eyes, we have tears that will hopefully catch the virus. In our respiratory tract, we have hair inside our nose. We have like mucus inside our lungs that traps the virus and helps us cough it out. And obviously our skin also protects us from the virus getting inside. But unfortunately, the virus can sometimes get inside. And so when it does get inside, that's when the adaptive part of the immune system comes into effect. And the adaptive part, we've got the specific and the non-specific parts of the adaptive system. So my son was just giving me a nice analogy about how, when I was explaining this to him, is if you imagine on a battlefield, you have foot soldiers. So foot soldiers that have no training in fighting in a war. And then you have trained soldiers. So imagine you go to battle. And initially, foot soldiers who are untrained are easy to get. So farmers, anybody are easy to get. But to train soldiers, you need lots of years of experience. So when the battle comes, you initially send out your foot soldiers who will try and keep the enemies away, but they're not very efficient because they haven't been trained. Meanwhile, you've got your trained soldiers at the back behind being trained. So when the war comes, the foot soldiers are trying their best, but the enemy gets behind before the trained soldiers are able to fight the war. So imagine the non-specific cells are your foot soldiers and the specific cells are your trained soldiers at the back. The time it takes for your trained soldiers to come into effect is the time that it takes for our body to make antibodies. So the non-specific cells are trying their best to keep the virus away, while our soldiers, our trained soldiers at the back are preparing to fight. So say you do this first war and you fail, obviously, because you don't have trained soldiers. The next time you go into war, your trained soldiers are ready to go. So as soon as the battle starts, the enemy comes, you've got your trained soldiers ready to go, and then they kill the enemies, and that's how that's the essential basis of your immune system. So the trained soldiers, the antibody, the cells that make antibodies, or the antibody cells, they take time to develop, but once they do develop, they are efficient. So essentially, this is just another picture highlighting that. So most of us would have been immunized against measles or have caught it, or chickenpox. So when measles or chickenpox or flu comes into our system, we've already got our antibodies ready. So your trained soldiers are there. As soon as the virus gets into the system, the antibody attacks it and kills the virus. But in the case of COVID, obviously, it's a new virus and we don't have antibodies to it. So when it comes, so that's when, so your enemy, if I use my analogy of the war again, COVID is your enemy. It's coming. You only have foot soldiers on the ground. So they do their best, but unfortunately, the virus is going to get past because our trained soldiers are not ready. So the way vaccine works, as we know, is what we do is we take a copy of the virus, but we weaken the virus. So it's not quite as disease causing. So it comes into the system, but it is enough to trick the body to think that, oh, the soldiers are, the enemy's here. And so it starts to train its soldiers ready to fight when the battle comes to it again. So you've got the virus there and you've got the trained soldiers being prepared so that when the real virus does come, your trained soldiers are ready and they're ready to go to kill the virus. Now, this picture is essentially showing us, this is the general structure of most viruses. Most viruses have this basic structure. They've got if people can see my pointer, So they've got the spike protein, which I'm sure we've all heard in the news, spike protein, this spike protein, that. Most viruses have the spike protein. And then the virus is inside this layer. So it's got a genetic material inside, which is covered in the protein coat, and another layer outside. So the way the COVID virus enters our system is that it uses the spike protein almost like a key, and then it goes into our cells, it unlocks our cells, enters into our cells, and then it releases its genetic material. Once it releases genetic material, it then uses our body's cells to make more viruses. So it uses our protein to make a protein coat for itself. It uses our lipid to make this membrane virus. Essentially, it's using us to make more viruses, and that's how the virus replicates. So what the vaccine people have done is that they've found the gene that makes this spike protein. They put that gene into the vaccine, and so that once it gets into our system, our body then it uses our body's system, just like the way the virus does, to make the spike protein. And once the spike protein is made, our body then recognizes the spike protein as an enemy and starts to train its soldiers to say, right, we found this enemy. Meanwhile, the foot soldiers are trying their best, but it's going to start training the trained soldiers to come and fight this virus, so that when you do come in contact with the real virus, you've already got your trained soldiers ready to go. This picture is just there to highlight the importance of herd immunity, just to explain to us what herd immunity means. So with every vaccine, there are some people that, for whatever reason, can't have it. Say they're allergic to the components, or they've got a medical condition, which means that it's not safe for them to have the vaccine, or they're babies, where the vaccine hasn't been tested on. So all these people are there and can be vaccinated. So the way we can protect these people is by more and more people in the population being vaccinated. And that's how you can protect the vulnerable who cannot be vaccinated. So if you look at my picture, say, if this lady is vaccinated, this man is vaccinated, this man is vaccinated, the virus comes to this woman has already got her antibodies ready. She kicks the virus off, it doesn't get to her. The same thing with this man. So these two have protected essentially this girl, because the virus cannot get past her to affect this one. And same with that. And that's the concept of herd immunity. So for us to be able to achieve herd immunity, more people, majority of the population need to be vaccinated to protect those that cannot be vaccinated. And hopefully we can get rid of the wild virus, and then it becomes a thing of the past. Just like polio has been almost eradicated in the whole world, smallpox has been eradicated, and that's all from, initially more people being vaccinated, and then the virus just dies out because there's nobody to infect, and then the virus dies out of the population. I hope this has been clear using my pictures, and thank you for listening. I will hand over back to Michael.
Thank you very much, Dr. Aisha.